Let's begin example 4. We'll first begin by just simulating this scenario one time, or really her career. So she's beginning at age 25, and you'll see I have each row represents an age. I've hidden most of the rows between row 23 and 46, but to 55. We'll assume that she begins with 0. The problem doesn't tell us otherwise. And every year she's going to invest $5,000. Her annual investment up in B5. I'm going to lock that. We'll see why in a second. The percentage return of this investment follows a normal distribution. This is more statistics class review. You recall what the normal distribution is. I'm going to pull up the probability review sheet. A normal distribution is centered around the mean, and it's a symmetrical mound-shaped distribution. So the distribution tells us what values the stock takes on and how often it takes them on. So I want to generate a percentage return here based on the normal distribution with a mean of 10 and a standard deviation of 6%. After you've added in YesI, we're going to select the gen normal function to generate values from a normal distribution. I'm going to choose the mean, lock that, and the standard deviation, also lock that. So it's generated a value of 20%. Yours will probably be different because it's generating a value from that probability distribution. So most likely our values are different. So my ending capital is going to be everything that I have invested, what I have on hand, plus what I've invested, times the percentage return. I'm going to do 1 plus the percentage return so that I calculate my final ending capital, not just the increase. Then Amanda turns 26, and now her beginning capital is the ending capital of when she was 25. From here, I'm actually just going to copy now all of my formulas down because I've locked them. Every year I'm investing $5,000. Every year the investment has a normal distribution return. And the ending capital is calculated the same way. Beginning capital also calculated the same way. So now I'm going to create a cell that tells me whether or not Amanda has met her goal. I'm going to use an if statement. She's met her goal if she has reached $1 million by the time she's 55. So if my ending capital when she's 55 is greater than 1 million, then let's do 1 for yes, 0 no, kind of that binary logic. So here it's simulated one time based on the randomness of the stock return. We did not meet our goal. But that's just one scenario. I want to replicate this simulation 1,000 times, and then in the long run look at how many times I did meet my goal, or the fraction of times the goal is met. I'm going to do that by running the YesI simulation. Before I do that, remember I need the sim output function. Select the cell or the function that we want the simulation built around, and then give it a name. I'm going to go up to YesI simulation. We're using 1,000 replicates. We're going to simulate this scenario 1,000 times. And I want to look at the fraction of times that the goal was met, or the average times. So right here, I'm just going to look at the mean. So of the 1,000 times that Excel ran the scenario, 43% of them, Amanda met her goal. So we'll estimate the probability of meeting that goal is going to be 43% probability. Your answer, again, might be slightly different based on the randomness of the simulation, but as long as you get an answer in the 40s, maybe 50%, you've done it correctly.